Hey guys, Mr. Dell here. We are looking at probability today in this video in regards to independent and dependent events. So with probability, things can be either independent or dependent, but if there's multiple events that you are analyzing. So this is CC2, this is CPM, and it's course 2, CC2, course 2, section 5.2.3, and specifically number 5-49 is the one I'm looking at. Okay, so it says, let's read this together, and then we'll go through each of these problem sets here. So for each of the following probabilities, write dependent. Okay, dependent what? Dependent if the outcome of the second event depends on the outcome of the first event, and independent if it doesn't. So dependent versus independent. So hopefully as we do these examples, you'll get a little bit of a sense of what does it mean to be dependent versus independent. And first of all, there has to be multiple outcomes or multiple events. I'll say that, multiple events. So for A, if we look at A says the probability of spinning a 3 on a spinner after you've just spun a 2, right? So if I have a spinner, I'm going to do my notes over here. I have a spinner, and I have a 1, 2, and a 3 on that spinner. And now I spin the spinner, right? I spin my spinner, my spinner spins, and I get a 2. I just spin a 2. Well, the probability of spinning a 2 was 1 out of 3, right? So now I'm going to spin it again, and it wants to know, spinning a 3, is the probability of spinning a 3, does it depend on what I got the first time, right? Well, I haven't changed the spinner, have I? It's still the same spinner, so the probability of spinning a 3 is still only is 1/3 because I haven't changed the spinner, right? So this, in this case, this is independent. These are independent of each other. They're not dependent. Independent. So it's an independent situation. What would make it dependent? What would make it dependent is if when I spin and I get a 2, then I remove the 2 from the spinner. So then my spinner all of a sudden becomes only a 1 and a 3, right? Because now I remove the 2, and now I only have a 1 and a 3. Now my probability changes because now there's only 2 possible outcomes, right? So the probability of getting a 3 this time would be 1/2. So the probability of getting a 3 would be 1/2 or 1/2. And so in this case, this would be dependent because it depends on what is being removed. But as is, it's only independent. All right, let's see a few more. Maybe that'll help as well. So the B, probability of drawing a red 6 from the deck of cards after a 3 of spades was just drawn and not returned to the deck. Okay, so in this case, I'm drawing a 3 and then not returning it to the deck. So does my probability change as if I was only going to be doing the 6 by itself, right? Yes, it does, because what happens is I'm not returning it to the deck, right? Not returning the deck means my total changes. So instead of a probability of something over 52, right? If it's a standard deck, it would be over 52. But now, not returned to the deck, it would be over 51. So I would have a situation where my probability changes. So in this case, it is dependent. Because the first event of drawing a 3 and not returning is affecting the next event, right? So it'd be dependent. C says drawing a face card from the deck of cards after a jack. So you drew a jack, and then now what's the probability of drawing another face card? But what do we say? After a jack was drawn and replaced and the deck shuffled. So I drew a jack, but I put it back in the deck, and then I shuffled the deck. So is my deck of cards any different than what it was before? No. I still have the same probability of drawing a face card. So in this case, the it's still over 52 cards because I'm putting the jack back and it's the same situation. So this one is independent. Independent. Okay. Because I haven't changed. The first event did not affect the second event. Okay, last one, D. So D says, selecting a lemon lime soda if the person before you reaches into a cooler full of lemon lime sodas and removes one and drinks it. All right, so you have a cooler full of sodas, and what's the probability of grabbing a lemon lime soda? Well, if it's only full of lemon lime sodas, it's a pretty good probability that you're going to grab one. But if it's got other sodas, then there could be some kind of, we'd have to figure out how many total sodas there are over the number of lemon lime. So my probability would be, finding the total sodas, total number, right? And then we'd have to find out what the number of lemon lime. I'll just say LL. So that would be my probability. Now, all of a sudden, the second time, what happens? That number decreases by one. The number, because somebody grabbed one and removed it and drank it. So now there's less. There's one less. So, and the total sodas decreases by one. So that's going to be a different probability the second time around. So that first event where somebody reached in and grabbed one changes the second event. So it's, again, dependent. All right, there we go. I hope that helped. Independent versus dependent.